For this problem, we're asked to use node voltage method to find the current I, which is going through the 6 ohm resistor. Okay, so we're going to identify two nodes, here and here, and then our reference node, which is ground, here. Remember, rule of thumb is to find the extraordinary node that has the most connections. It's a good reference point. Okay, so this will be V1, this will be V2. All right, so now we're going to write KCL for each of our node voltages. So KCL at V1 is going to be V1 minus 5.3 over 4 plus V1 minus 0 over 3 plus V1 minus V2 over 6 equals 0. Now for KCL at V2, it's going to be V2 minus V1 over 6 plus V2 minus 0 over 12 minus Ix, which equals 0. Now a quick note about writing the equation for this term and this term. Okay, so I is already defined for us, and if we're using passive sign convention, then it's going to be in the direction of the voltage drop. Okay, so I is V1 minus V2 over 6. Now notice that in this equation, I wrote V2 minus V1 over 6. That would actually define I in the opposite direction. Okay, which would be going out of that node. All right, so but what I decided to do is to define it like this, since eventually if I was defining it as going out, it would be positive. If I was defining it as going in, which is this V1 minus V2, then I would subtract it out anyways, and that would fall out in that way. Okay, so now I have these two equations and I have three unknowns, but what I can do here for Ix is replace it with 2I, and like I just said, I know I is V1 minus V2 over 6, which gives me two equations and two unknowns. Now I'm going to simplify my equations, and I have 9V1 minus 2V2 equals 15.9. That's from my KCL at V1. And I have minus 6V1 plus 7V2 equals 0, and that's from KCL at V2. Okay, so if I solve those equations, I'm left with V1 is going to be 2.18 volts. V2 is going to be 1.87 volts. And that means Ix is going to be V1 minus V2 over 3. Remember, since it's 2I. And that gives me 0.1 amps. Okay.